Hello, and welcome to Calculus Lesson 25. Today, we're going to cover another trick that's going to allow you to find the derivative quicker for some of our functions, and we are going to talk about derivatives of sums and differences. So let's get right to it. Today, or last lesson, we learned that the derivative of x to a power, so this is a real number, in fact, it is a real number, is that number times x to the n minus 1. So if we add x cubed, we did 3. This notation means the derivative, in case I didn't mention that. Then we have 3x to the second, because n was 3. Now, today we are learning how to take the derivative of a function times a constant. Okay, so how do I do that? Well, it's actually pretty simple. And I am going to illustrate this by using a proof, of course. So let's say our function is some constant times some other function. We don't really care what g of x is, we just want to know how do I find the derivative and deal with that constant. So f prime of x will be, of course, the definition of the derivative, which is the limit as h approaches 0 of f of x plus h minus f of x over h. Now, what do I do with that? Well, I am going to evaluate these functions. So what is f of x plus h? Well, the c really doesn't matter, right? So c can stay outside, and it looks like that'll just be times g of x plus h minus f of x is c g of x divided by h. Now you might look at me and be like, what do we do with that, right? We don't even know what g of x is. That's totally fine, because check this out. I have c in the top on both parts, so I can factor that out. Since it doesn't depend on h at all, I can take it outside of my limit. So you're allowed to take things outside of your limit if you can multiply them, right? So it's c times this whole thing that I'll leave there, and as long as it doesn't depend on your variable of the limit, which it doesn't, because c is a constant. It's going to be a number. Now, what am I left with? I'm left with the limit as h approaches 0 of g of x plus h minus g of x over h. Does that look familiar? Well, yeah, that's simply the g prime of x. That's the derivative of g. It's the definition of the derivative. So what do we find? We found that the derivative of a constant times a function is simply the constant times the derivative of that function. So this is your second quick rule of derivatives. In case you missed your first one, that's up here. All right, so how would I use this? Well, it's actually pretty simple. Let's say we want to find the derivative of 20x cubed. The trick is that I don't worry about the 20. You just leave it there, right? You leave it in front and you evaluate the derivative of the actual function that you care about. So I'm going to leave the 20 there, and now I'm going to evaluate the derivative of x cubed. We already said the derivative of x cubed was 3x squared. And so that's 120x squared. All right, so the 20 comes out. As long as it's multiplied by your function, you can pull it out of the function there. Let us do, we're not going to do another one. So the last thing that we're going to talk about today is derivatives of sums and differences. So if I have a function f of x, and I add it to g of x, and I want the derivative of that, what will it equal? Well, there is a proof in your book, and I would encourage you to read through that proof in lesson 25. But I'm going to tell you that this is simply the derivative of f plus the derivative of g. So as long as they're not multiplied by each other, they simply add the individual derivatives. So let's take the derivative of something fun like 20x cubed plus 3x squared. First of all, I'm going to take the derivative of this part and add it to the derivative of this part. That's what we just learned. You can split the derivatives, and it's just because you can split the limits, right? But you can split these. Now, I'm going to take the derivative of the constant. Since it's multiplied by my function, that just comes out front. And this 3 can come out up front. What's the derivative of x cubed? It's 3x squared, so this will be, wow, I got away with 20 times 3 is 120. That's sad. That's 60. The book didn't even tell me I was wrong. Man. So 20 times 3 is 60, x squared. Maybe it is a good thing to skip showing your work. No, it's not, right? Because I got it wrong. Anyways, here the derivative is 2x, so 3 times 2x is 6x. Success! That is our solution. And so, as you guys think about this, just remember, you've got this, all right? Have a great day and enjoy problem set 25.